and we'll do a little bit on flower processing today. And that is you, Gary.
Okay. So before we get into the specifics about flower processing, I think it's important to understand how a cut flower takes up water in solution. So we're going to look at that mechanism next. So only a small percentage of the cells in the stem are composed of the xylem vessels. So what you can see in that photo on the lower left is a cross section of a rose stem. And what was done here, it was placed in a pressure vessel, and a solution with a dye was forced up through the stem. And you can see the pink areas, or the stained areas, are the actual areas that are conducting the solution. So most of that stem is not conducting water or nutrients up the stem. So the water conducting cells are really very limited. If this were a flower growing in the field, the roots would provide pressure to push the water and nutrients through the stem. And in the diagram in the center, we can see water and nutrients are being transported in one direction up the xylem, which is kind of the plumbing system. And another group of specialized cells called the phloem, which transports sugars made in the leaves and in the stem up or down to the flower or to the roots. So the xylem flows in one direction, transporting water and nutrients up from the roots, and the phloem is bidirectional, transporting sugars and other compounds from the leaves up to the flower or down to the roots. But because our flower is cut and has no root pressure, how does it conduct water up the stem? And the answer to this actually lies in the leaves, and to a lesser extent, the flower petals, which are essentially modified leaves. So the underside of the leaf contains microscopic pores that can open and close, and you can see photos of those on the right. And these pores are called stomata. And like I said, they occur primarily on the underside of the leaves. And as water evaporates through these stomata in the leaves, it creates this concentration gradient and pulls the water up the stem in the xylem in a process that we call transpiration. So we're using a lot of scientific terms, but what you really need to remember is that in many cut flowers, the foliage plays a very important function in keeping the flower hydrated. And this is why we recommend leaving some leaves on the cut flower stems when you're processing them. So with something like a rose, we always recommend leaving 1 or 2 sets of full leaves on that rose to help facilitate the uptake of the water. Okay, we'll go to the next slide. So really, movement of the water up the stem into the flower is a balance between water uptake and water loss through transpiration. And in this graph, on the x-axis, we have the percentage of the initial weight of a flower on the y-axis, and the number of days in a vase on the x-axis. So at day 0, we're at 100% of the initial weight. And within 3 days in a vase, we're showing that uptake is greater than transpiration. So the flower is gaining weight. It's taking up solution and it's getting heavier. But then at one point, uptake begins to equal transpiration. And then finally, transpiration starts to be greater than uptake. And when this happens, the flower starts to lose weight, and eventually the flower wilts. So what may be happening here is maybe the xylem is getting clogged with bacteria, or there's some type of blockage or air bubble, and it's preventing water from moving up the stem, but water is still evaporating out of the leaves during transpiration, and the result is the flower starts to wilt. And in the next slide, we're going to show an example with hydrangea. So in this photo with hydrangea, which is a notoriously heavy drinker in the cut flower world, we're we're demonstrating the role of the foliage in water uptake. So we have 4 vases, and on the far left, we basically have an intact flower. We have all the foliage, all the flowers, and the stem. In the second vase, what we've done is we removed all the leaves from the hydrangea. So we just have the flowers or the bracts and the stem. And in the third vase, we just have stems. Fourth vase, we just have vase solution to account for evaporation. And the orange lines actually represent the solution level in these vases. And this photo was taken on day 5. And what we observed is that the flower food uptake was reduced by 75% when the foliage was removed. So it just demonstrates how much of a role the foliage plays with a flower like hydrangea and how much solution that it takes up. So when you're designing with a hydrangea, obviously you want to have some foliage for the aesthetics, but think of it as a balancing act. If you leave too much foliage on that stem, it may cause it to lose too much water and wilt faster. So just leave enough foliage for the aesthetics and for good water uptake. Okay, next slide, please. Right, so now that we know how the water moves up the stem, it's important to discuss the importance of water quality. And water quality can vary depending on your geographic location and your source. So you can have city water, well water. Some places might even use rainwater. So flower foods come in concentrated liquids and powders, and they're ultimately mixed with water. And once they are, 98 to 99% of that is water. And the quality of the water can have a great impact on the effectiveness of the flower food. So it's important to have your water tested. And in the next slide, we're going to go over the different parameters that you want to look at. Okay, so these are a list of the different water quality parameters that we look at to determine water quality. And the first is pH. And you may remember pH is really a measure of how acidic or basic something is. And it's measured on a scale of 1 to 14. So pure water comes in at a pH of 7. If you're below 7, it's considered acidic. So something like vinegar would have a pH of around 3, that would be considered acidic. And above 7 is considered basic. And for cut flowers, we're looking for a pH somewhere between 3 and 5. This is kind of the optimum pH because it facilitates solution uptake. And one thing flower foods do is they acidify your water into this range, and this is something we'll discuss in more detail later. The other property, and this is probably the most important one, is called alkalinity. And it's a little confusing because it sounds like alkaline, which is synonymous with higher pH or a basic pH. But alkalinity, what it is really it's the measure of the carbonates and bicarbonates in your water. And these compounds resist or buffer acids. So think of them as eating up acid. So if your water has a very high alkalinity, when you add the flower food at the proper dose, it may not lower the pH into the optimum range. And you may find you have to double the dose to get to that pH range, and you don't want to do that. You never want to add flower food higher than its recommended rate, and we'll discuss that later in the presentation as well. So in this case, if your alkalinity is very high, you might have to use a specialty flower food in order to get the pH where you want it. And finally, we're going to talk about hardness. And hardness is usually related to alkalinity. Usually when you have high alkalinity, you have high hardness, but it's not always the case. Hardness refers to the level of calcium and magnesium in your water. And if your water is very hard, these minerals are what cause kind of the scaling deposits on your glassware and your pipes. So they can be problematic in that respect, but these minerals can also be beneficial for flowers at moderate concentrations. So the opposite of hard water is soft water. And soft water is naturally found around coastal areas, and it's high in sodium. And high sodium is not good for flowers. And many people with hard water have a softening system installed. I have well water in my home. We have a water softener to prevent all those mineral deposits. And what a softener does is it exchanges those calcium and magnesium ions for sodium. And this helps prevent the scaling in your dishwasher and your bathtub, but it's bad for your flowers. So see that list stated in red here. You do not want to use softened water with your cut flowers. It's best to bypass your softener and use the hard water instead. And finally, I just want to mention that there have been reports that florists can use reverse osmosis water or DI water. I think several years ago, it was a popular thing, but what happens with something like reverse osmosis systems is that it's removing all the mineral salts out of the water. And this is not good for flowers. Your flowers want some type of mineral salts in there. It helps facilitate uptake. And if you have super pure water with no minerals, it actually impedes uptake compared to water with salts. So we do not recommend using reverse osmosis water or deionized water or distilled water for your flowers. Some places that have very hard water, what they'll do is they'll install a reverse osmosis system, but they'll back add some of the hard water to get the salts to a moderate level that's right for the flowers. So generally, flower food formulations perform just fine in all but the most extreme water types. And in these cases, there are specialty flower foods that can be prescribed. And we could devote a whole presentation to water quality, but for now, the take-home message is to have your water tested. It's a service that Floralife does provide, and we can give you the parameters of these chemical properties: pH, alkalinity, hardness, and conductivity, and prescribe the right flower food for you. And the final thing I want to point out is cold water is the best for flowers. Think of it just like cold temperatures. So there really is no need to put your flowers in warm water unless you're an event planner, for example, and you have some lilies you want to force open quickly. Then putting them in warmer water at room temperature will do that. But if you're talking about just what's the best way to treat your flowers, process them into cold water and get them into the cooler. Okay, and I think the next slide is yours, Bruce.
Yep. So how do we do all this? So first of all, we talked about making sure everything's clean, stripping the foliage. You do not want to cut stems underwater. I pulled out my sister's old underwater cutting thing that I'm sure a lot of you have seen. Underwater cutting was shown to increase hydration in the lab. But one of the things they found out that in the real world, if you cut underwater, that underwater cutting tub, you cut 3 to 4 bunches of flowers, and that solution in that underwater cutting tub is going to have more bacteria than there is in the air. So you want to just cut in air, and we'll talk about a hydration solution in a second that does help some of that issue as far as the, cutting in air. And obviously we've talked about cutting direct sunlight, and then don't place flowers too close to fruits and vegetables. The other thing to remember is you cutting stems at an angle versus straight across makes no difference in hydration. I know people will want to cut at an angle for stem insertion, but there is no truth to the fact that if you cut the stem at an angle, it's going to hydrate faster than if you cut it straight across. Think of it as if you bundle up a bunch of straws in your hand and cut them, you're still going to have a bunch of little circles left, no matter if you cut it at an angle or you cut it straight across. So, and we don't really care if you use a knife or a cutter, as long as it's sharp and clean. So I'll step into just hydration solutions quick, and then we're done for today. So we want to talk about what does a hydration solution do. That would be your first chemical use beyond the cleaners at this point. And hydration solutions have 2 of the 3 ingredients in a flower food. So it's acidifiers to bring down the pH, which Gary talked about. And then what we like to call stem unpluggers, chemicals that can keep the stem free flowing. And really the easy way to look at it is it just gets your flowers ready for a flower food solution, gets them all dressed up, ready to go. So the third ingredient that is not in a hydration solution that's in a flower food is the sugar, which is the food. And I'm primarily going to talk about Quick Dip here, and it's all about implementation. So we sell other hydration solutions that you can use. The issue, as far as I'm concerned, in my years of going into all types of floral operations, is implementation. So the 2 things that come with any other type of hydration solution is mixing, which isn't good, and the other critical thing is time, because most of them have a time limit on how you use them. The reason I like the Quick Dip is you really can't screw it up. So you use it straight, you pour it into a container, usually 1 to 2 inches deep. You cut your stems, you dip for a couple seconds, and you go into your flower food. So this picture here, once again, all other variables removed, just shows the difference on these 2 varieties of roses by using Quick Dip and going into water versus not using Quick Dip. So think of the hydration step as the prep your flowers need before they go to eat lunch or something to that effect. And it also, the Quick Dip will also counteract some of the negative effects of cutting in air. One last thing, I forgot, I want to bring it back up. If you think about what Gary talked about with leaves, understand why you may have problems with Gerber daisies. They have 2 inherent qualities. One, they have no leaves to draw a solution. And the other is they've got that fuzzy little stem that is a magnet for bacteria. So cleanliness is everything with Gerber daisies, and understand why they don't like to drink. They really don't have the genetics to do it.